वेलकम टू योर चैनल बी ऑलवेज लर्नर। इस वीडियो में हम इलेक्ट्रोमैग्नेटिज्म को अंडरस्टैंड करने के लिए मैग्नेटोमोटिव फोर्स को अंडरस्टैंड करेंगे। आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए और चैनल को सब्सक्राइब करिए। मैग्नेटोमोटिव फोर्स इज एनालॉगस as we are already understand EMF in electrostatics. That is, EMF represented by EMF Electromotive Force. Now, this EMF can be understood by, if we are having a source of energy that is represented by EMF and some source is there, that is EMF, which is connected to a load. Here we are going to consider the lamp as a load. So this is the lamp. As this EMF is connected to the circuit, then the electron starts flowing. Because this EMF is give the force to the electrons to move. Now there is a current is going to flow, because current is going to flow because of the flow of electron. Now it means the reason for the flow of the current, because there is a thrust, as we can say, that is input force. So that's how we can call as electromotive force. So it means कोई भी अगर आपके पास सोर्स है तो उससे इलेक्ट्रॉन्स अगर मूव करते हैं तो हम इनपुट में फोर्स अप्लाई कर रहे हैं, राइट? सो टू गिव द इल्यूमिनेशन टू दिस बल्ब, एंड दिस current is going to flow like this, right? So that is what it is. Similarly, when we are talking about the magnetic field, then we can easily get the knowledge about that. If we are having a magnetic circuit in the form of core, iron core, so this is iron core, and some source of input is connected, and we are wounding the wire. हम इस तरह से वायर को लपेट देते हैं और यहाँ पे हम कुछ सोर्स लगाते हैं, that is V, having V voltage at the input side, and that is the reason कि यहाँ पर एक करंट फ्लो होना शुरू होगा. और जब यहाँ पर करंट फ्लो होना शुरू होगा, राइट, एंड दैट वोल्टेज इज AC वोल्ट, अल्टरनेटिंग करंट. जब करंट फ्लो होना शुरू होगा और यहाँ पर जो हमने नंबर ऑफ टर्न लपेटे हैं, कितने लपेटे हैं? सपोज नंबर ऑफ टर्न्स आर N. सो दिस N and I is going to generate a force which is going to generate a flux. We call it magnetic flux. And this magnetic flux represented by phi, we call it magnetic flux, right? So this magnetic flux is depending upon few things of this core property, or we can say the core material property. उसके ऊपर फ्लक्स डिपेंड करता है, राइट? सो दिस कोर इज अ मैग्नेटिक मटेरियल और नॉट, बाकी चीज़ों के ऊपर डिपेंड करता है कि फ्लक्स किस अमाउंट में फ्लो होगा, राइट? सो इन शॉर्ट, बैक टू द टॉपिक, वी कैन कॉल इट मैग्नेटिक मोटिव फोर्स. जो फोर्स यहाँ से इनपुट में रीजन बना है फ्लक्स को फ्लो कराने का, वो क्या है? नंबर ऑफ टर्न्स एंड करंट फ्लोइंग, राइट? सो द रीजन So the reason for the flow of current is a current, region of flow of flux is the current, and the number of turns. We can simply write turns in initial phase. So these are the two main reasons which is give a force or a force to the or to generate the flux into the magnetic circuit. So the definition of magnetomotive force, that is MMF, is, we can define that it is a pressure that tends to set up magnetic flux in a magnetic circuit. So this N and I is the reason to generate a pressure to flow of or to generate of magnetic flux. So mathematically, if we can define that MMF is the product of current and the number of turn N, product of MMF and number of turn N. So it means it is represented by Ni, right? In the same way, we can talk about the unit also, unit of MMF. अब यूनिट्स क्या होंगी कि करंट की यूनिट हुई एम्पियर. सो वी कैन से दिस इज एम्पियर and the turn N is number of turns, so we can say this is turn. So ampere turns, in short we can write AT. AT is the unit of MMF, right? So that's how we can define the MMF. And readily, when we are talking about this magnetic circuit flow of this flux is depending upon, as I said, that is depending upon the core material, and it is also depending upon the length of the magnetic circuit, that is represented by L, and the area of magnetic circuit, and also it is depending upon the permeability. So that is nothing but we call it length, and this is nothing but area, and this mu is permeability. तो इन चीज़ों के ऊपर डिपेंड करता है कि फ्लक्स कितना जनरेट होगा किसी मैग्नेटिक सर्किट में, एंड हाउ इट्स गोइंग टू फ्लो इनटू द सर्किट. नाउ अगर हम परमेबिलिटी की बात करते हैं तो देयर इज अनदर थिंग कम्स इनटू द पिक्चर हियर, जिसको हम बोलते हैं रिलक्टेंस. रिलक्टेंस इज इक्विवेलेंट टू द रेजिस्टेंस. रेजिस्टेंस क्या करता है? अपोज करता है करंट फ्लो को इन इलेक्ट्रोस्टैटिक्स. इसी तरह से रिलक्टेंस इज अ opposition for the flow of flux, right? So analogically we can write that MMF is equal to MMF अगर एक वोल्टेज है, so voltage is equal to what? Current into R in case of electrostatic. In case of magnetostatics or magnetic circuits, we can write MMF is equal to, we can write magnetic flux into reluctance, right? So that's how we can write. So magnetic flux is equivalent to the current, and this reluctance is equivalent to the resistance, right? So we can say this formula can be modified by MMF, writing by mmf is equal to flux is represented by phi, and this reluctance is generally represented by S. So the formula becomes phi into S. Now this S is a reluctance which is equal to the length divided by area and the permeability of the material and the relative permeability mu r. So that is the formula to calculate S. So if it is so, then we can write that mmf is equal to phi L A mu naught and mu r. In another sense, we can also convert this flux per unit area in B, that is density, flux density. So the flux density that is represented by B is equal to phi by A, that is B multiplied by L divided by mu naught and mu r, right. So that's how we can also calculate the mmf, which is a relation of the flux density, length and the permeability. So that's how we can understand the magnetomotive force. In the coming videos, we are going to discuss the reluctance also. We'll provide the link into the description box so that you can understand in detail. So hope you like the video, and please subscribe the channel and do not forget to press the bell icon.